Thank you, everyone, for joining us tonight. So now we're going to start the meeting. We're going to start by approving the minutes of January 15th, 2025, the last EAB meeting. Do we have a motion to approve the minutes? All in favor? The minutes have been approved. So today we're, Ms. Bailey, would you like to introduce our speaker?
Sure. So I'm delighted that we have Sarah Malin with us tonight. She's going to talk to us about a topic that's very important to Long Island, the results of the sustainability study of our aquifers that the U.S. Geological Survey has been working on for the last few years. And Sarah has a dual background in water resources management and law. So she's in a good position to address water issues from a dual perspective. And she was the director of the Center for Water Resources Management at New York Institute of Technology.
Recent study that is still ongoing. And so this is going to be an advanced course in hydrology. I'm going to assume that most of you have a baseline level of knowledge about the aquifer system. I know Liz is a great teacher, so I'm sure you've picked things up from her. And I'll try to be as clear as I can. I think maybe about halfway through, I'll pause for a minute and see if there are any questions about what I've covered so far, and then I'll finish up if that's okay. So you don't have to wait too long if you have a burning question that you want me to answer for you. So what I like to do in my presentations is to just remind everybody about what a couple of terms that will come up over and over again mean, just so we're all clear about it. First of all, the question often comes up is, what is an aquifer? So an aquifer is simply a geologic formation that can perform three functions. It can transmit water, it can store water, and it can yield water. And by that, it means water can move through it, water can be held within it as sort of a storage container. And then if you want to get that water out, it can be produced relatively easily in usable quantities. We have a variety of aquifers here on Long Island. They work together as a system. And our aquifers are made primarily of sand and gravel. We do have clay mixed in with parts of our aquifers. Clay is not an aquifer because it doesn't do all three of these functions. If the formation doesn't do all three, it's not an aquifer. It can still hold water or whatever, but it doesn't meet the definition. And the other two terms that will come up will be groundwater. And groundwater is simply the water that is stored in formations that we call aquifers. And the term water table. So if you know what a lake is, the top of the water in the lake we call the water surface. And there's a similar feature in a groundwater system, which is the top of the groundwater itself that's being stored in the aquifer. And we call that feature the water table. It's relatively flat, but it's not perfectly flat. And we'll see some examples of what that looks like a little bit later on. So I'm here to give you an update on a study that began in 2016. It was a joint project between the U.S. Geological Survey and the New York State Department of Environmental Conservation. And it was a Long Island groundwater sustainability study. And there were some specific goals that had been set for this study, and they're listed here. One, we wanted to update the scientific knowledge of the aquifer system. The USGS calls how the aquifer system is built, they call that the framework. And this information about the framework or the details of the various aquifers was more than 40 years out of date when this updated study began. The study looks at how the system has changed over 120 years from the year 1900 to the year 2019. It was intended to build a new and sophisticated computer model of the groundwater system. It's very advanced, it's very complicated, and it has been built now, and it is being used for the study. What the model is intended to do is to take the different conditions of the aquifer and then change those conditions and predict how the aquifer will respond to these changes. And these conditions are considered what we call hydraulic stresses. And so it's things like drought, climate change, high pumping rates, precipitation, sea level rise, all these different variables. As we mix and match them, how will the aquifer respond to new conditions? And that gives us an idea of management efforts that we should anticipate will be needed in the future. And then a very important goal was to identify the boundary where the freshwater and the saltwater come together and what we call the saltwater freshwater interface. We know that that interface or that boundary area is moving inland underneath the island, and it's putting water supplies at risk. And so we wanted to know exactly where that boundary was, because we have not known that with great confidence in the past. So the phase 1 part of the study, and the study's been broken up into 3 parts. Phase 1 looks at Nassau, Brooklyn, and Queens. Phase 2 looks at Suffolk County. And then phase 3 is kind of like a picking up anything that didn't get addressed in the first 2 phases, or where we found we had areas where data was missing, and we would make sure that we collected data from those spots. So this is looking at a couple of the reports that were produced and released in 2024. The report on the left is the report about the framework of the aquifers. The report on the right is a report on using the computer model and running through various scenarios and seeing what the model predicts for us in the future. In addition to these 2 physical reports, there was a map viewer, as the USGS calls it. It's an interactive computer simulation that you can do online, and it's available to anyone. And it's basically a mini version of the computer model, and you can go in and select the variables that you want and the time frame and so forth. And then it will generate the maps that were the output for the model itself. So you can, if you have areas of concern or areas of interest, you can go in and run the model yourself and see what it predicts. And then finally, the USGS posted the actual computer model information, the algorithms that the model uses and all the data that was behind the model. So for consulting firms, this is like a gold mine for them for future business. This is a map of the study area itself. So on the right, you see Nassau County, in the middle is Queens, and on the far left is Brooklyn. And then it includes also the seawater and the coastal areas around the coastline of these three counties. The brown area is one of the many mountain ranges that runs the length of Long Island. This is the northern terminal moraine, and it's called the Harbor Hill Moraine. There's one that runs along the north side of Long Island, which is the one you see here. It goes all the way out to the North Fork, and then there's the second one that runs down more toward the South Shore and forms the backbone of the South Fork of Long Island. And so the browner the area is, the higher the land elevation above sea level. So these lands are the highest parts of Long Island elevation-wise. And the highest area of all is right along the Nassau-Suffolk border on the right-hand edge of this area. The green dots, if you can see them, they are where additional deep monitoring wells were installed as part of the study to collect additional information. This is our typical view of the aquifer system on Long Island. You can see that if we could take a knife and cut the island in half, we'd see these various layers like a layer cake that are stacked one on top of the other, and they're slightly tilted. So the Long Island Sound is on the left on the North Shore, and the Atlantic Ocean is on the right on the South Shore. And you can see that these different layers get wider as you go from north to south, and they get deeper. And the different layers start at the top. The topmost layer is called the upper glacial. And then beneath it directly is a small system that is made up of the gardener's clay, which is that purple layer. And then below it is that kind of rust-colored layer, which is the Jamico aquifer. So the gardener's clay is not an aquifer, but the Jamico aquifer, as you can see, is. And then beneath that is the major aquifer, the Magathy. And this is the most significant aquifer because it holds the most water. And for us in Nassau County, this is the main source for our water supply. Below that is a thick layer of clay that's several hundred feet thick called the Raritan clay or the Raritan confining unit. And then beneath that is our final aquifer formation that sits on bedrock, and it's called the Lloyd aquifer. And the water is always moving through the aquifers. It falls on the land, it sinks through the soil and into the formations that hold the water. And then that water continues to move either to the North Shore and discharge into Long Island Sound, or to the South Shore and it discharges into the estuaries in the Atlantic Ocean. And the dividing line determining which direction the water flows is that red line that runs along the top of the island there that's called the groundwater divide. So this groundwater divide is basically tracing the highest elevations on the moraine that I pointed out earlier. So this is what we have relied on in understanding how the system is made up for decades. But it doesn't really look like this anymore because we've added a lot to it as a result of the study. And I'll show you some new information about where these formations really exist beneath Long Island. So the main formations that we are familiar with up to this point were the upper glacial, Gardener's clay, Jamico Aquifer, Magathie Aquifer, Raritan Clay, Lloyd Aquifer. Those 6 were the key to understanding Long Island. One of the things in this report is that it combines some of these aquifers together as a unit. So the report will talk about the UJM, and by that it's talking about the Upper Glacial, the Jamico, and the Magathie, and it describes them kind of as a unit. And then it will also talk about the NSL, which is the North Shore Aquifer, which I haven't spoken to you about yet, and the Lloyd Aquifer. So you'll see those abbreviations coming up occasionally, and that's what they stand for. So here is the more complex understanding of where aquifers are and what they're made of. And how they relate to one another. So the upper glacial aquifer has now been characterized into 3 formations. One is the moraine, one is the outwash plain, and one is the ice contact. So the moraine is in the center, the outwash plain is to the south, and the ice contact area on the North Shore is to the north. We also have a Smithtown clay, which I didn't talk about. We've got the 20-foot clay. Then the new formation is the North Fork clay. And then on the right, you'll see under the Jamico, 2 new formations, the North Shore clay unit or confining unit and the North Shore aquifer. Then we come to the Magathie, and then under the Magathie, sitting on top of the Raritan clay is a brand new aquifer that nobody knew about until this report, and it's called the Upper Raritan Aquifer. And I think what happened here is it was known that the Magathie, the bottom of the Magathie was had a lot of gravel in it. And so I think the USGS just decided that they would make that its own aquifer, and they're calling it the Upper Raritan Aquifer. And then we go down below the Raritan clay and we get to the Lloyd, and then we come to bedrock. So you can see that the system is getting more complicated as we learn more about it. The reason that it is important is that when we want to understand how water is moving through the system, once we realize that there are all these intermediate formations that we didn't really recognize in the past, it can have an influence on how water actually travels through the aquifer system as a whole. So let me just back up for a little bit. Long Island as we know it today is not the Long Island that it was in the past. And the reason is that during the past glacial events that go back starting about 120,000 years ago and coming up to today at about 20,000 years from today, the North American continent was covered by a very large ice sheet. And that ice sheet moved down from the north and covering the whole northern part of North America and out into Alaska and all of Canada. And the leading edge of the ice sheet stopped right in the New York area. And you can see that red dot there on the right, which is the New York Bight, is the canyon that, the subsurface canyon that was created by the Hudson River. And Long Island was right there next to this area. So you can see that we got some debris from the glacier, and I'll show you that in a little bit better here. So this is another look at the coverage of the ice sheet. And you'll see off on the Atlantic coast that there's the coastline, and then there's a dashed line further away. That is where the ocean and the shoreline was during the Ice Age. because so much water had been trapped in the ice, it lowered the sea level by hundreds of feet. And so Long Island was right at the spot where the ice stopped and then receded. And that's why we have those hills that we call moraines, which are glacial deposits when the glacier stopped progressing and started to melt away. And to appreciate how far offshore the shoreline was during the Ice Age, this is a close-up. You can see Long Island up on the north side of the right-hand top side of this slide. You can see the two moraines and those lumps there that are the Harbor Hill moraine to the north and the Ronkonkoma moraine to the south. And the gray area up here is the area where the glacier was. So you can see that it just came onto Long Island and then it pulled back when the glaciers started to recede. And then that green area was not glaciated, and the rest of New York State was all covered up with ice. And if you look to the far right, you'll see a red line. That is where the shoreline was. And the distance between the Long Island as we know it today and the shoreline and where the shoreline was during the Ice Age, that's over 80 miles offshore. A lot of us don't really understand that the shoreline was so far away from where it is today, but that's where it was. So Long Island was entirely different. All of that area to the south of Long Island would have been free of water, and it would have been bare land. So this is an image of a satellite image of a sort looking at the moraines. And you can see the Harbor Hill starts actually in Staten Island and then comes across and is at the tip of Brooklyn, goes all the way along the North Shore and extends out to the North Fork. And then the Harbor Hill moraine starts roughly around the central area of Oyster Bay, and it extends toward the South Shore and then extends out into the South Fork. And the Harbor Hill moraine actually extends up into Cape Cod. That formation of the terminal moraine doesn't exist just on Long Island. And what this is all the debris that was at the front end of the glacier, of all the materials that had been picked up as the glacier slid across the landscape like a big bulldozer. And then when the glaciers weren't moving forward anymore and started to melt back, that debris just was left in place. And so these were much taller, several hundred feet above sea level. And then over time, this debris in the moraine got spread across the landscape into what are now these three different components of the glacial aquifer. So on the south side of the moraines, the land is relatively flat. Then you've got the moraines, which are hilly, and then you've got the North Shore, which is got a very irregular coastline. It's slope, has some steep slopes in there, and a lot of different debris than the South Shore. So this is the three areas of the glacial aquifer. The yellow is the outwash plain, which is mostly sand that washed down from the hills. Then you've got the red area, which is the moraine itself. And this is the high point. It's got a lot of just jumbled rocks and stones and big boulders, just about everything you can imagine in there. And then on the backside, this is where the glacier actually came in contact with the North Shore, the backside of Long Island. And this was heavily impacted by the glacier itself and disrupted a lot of the aquifers that were already in existence on Long Island. And we'll see some indications of that a little bit later on. So now we see that the glacial aquifer is not just one homogeneous mix of materials. It is made up of 3 different types of materials, all coming from the moraine itself. So this is a statement from the report, and it says the groundwater system in Western Long Island has been under stress from the pumping of public water supply wells, irrigation or golf course wells, and industrial wells. So it's saying flat out that the aquifer is under stress from pumping. It also found that large-scale withdrawals of groundwater since the early 20th century resulted in the reduction in the volume of fresh water in the aquifers of about 5% since major pumping began in 1900. So we've got this 5% reduction in water being held in the aquifer. And people can have different reactions to the 5%. One reaction might be, well, 5% isn't very much. You know, we're doing pretty good. And the other thing is to realize that a mere 5% in the change of water in storage in the aquifers is resulting in some very serious changes to the system that are not going to be changes that we humans are going to like very much, including saltwater intrusion. So this is the relationship that determines if an aquifer system is healthy or not. And it's a very simple relationship. And so you've got, on the one side, on the left, you've got water coming into the aquifers. We call that recharge, and this is mostly rainfall. Falling on the land, water seeps into the ground. That amount of water needs to be equal to the 2 components on the right. Water that's naturally leaving the aquifer or being pumped out, and water that stays behind in storage. So what this is saying is that when these relationships are equal, the material, the water on the right equals the water on the left, the water on the left is equal to the water on the right, then that system is in balance and it's healthy. If it's out of balance, then the aquifer is going to respond and is not a healthy aquifer any longer. So we're dealing on Long Island with an interesting situation, which is in Nassau County, the system is not in balance. In Suffolk County, the system is basically in balance, and they do not see the same problems that we're seeing here in Nassau or in Brooklyn and Queens. This is a graph on the left that is from the report, and it looks at all 4 counties and looks at their history of withdrawing water from the aquifer system. So starting on the left, back in around 1900 and going all the way to the year 2019, we see the history of groundwater withdrawal by the 4 counties. The light blue on the left, that line on the left, is a graph of water being pumped out of Brooklyn. And you see that it starts very rapidly, goes until around 1940 or so, and then tapers off to 0. That's Brooklyn. Along the same time, the green line is the pumping in Queens. And you can see it grew even higher than the pumping level in Brooklyn, and it lasted for far longer and continued into the late 1990s and early 2000s. The light purple line is Nassau County. And so the pumping in Nassau started around 1920. You can see it climbed very high and then kind of leveled off, and now it's starting to decline a little bit. And you can see that on the right. And then the dark purple is Suffolk County. And it's hard to see on that graph, but pumping started in Suffolk around the 1950s. It grew very rapidly, and now it is the largest withdrawer of groundwater on Long Island, has the largest amount of withdrawal in Suffolk County, much greater than Nassau now. And they are continuing to increase their rate of withdrawal in Suffolk County. The pie chart on the top right, the red one, shows who's using the water. And you can see the dark red represents 88% of groundwater use. That's the public, that's us. So we collectively, of the public, are the largest consumer of groundwater. It's not agriculture, it's not business, it's not industry, it's none of those things. The commercial industrial use is only 10%. So what happens to the groundwater system is due to our own use and demand for water. The chart on the right, the pie chart on the right, is showing which aquifers are relied on for how much water. And you'll see that on this chart, it says the glacial aquifer provides almost 55% of all the groundwater used on Long Island. And the Magathie only represents 28% of all the water. The Lloyd is 1%, the Jamico is 12%, and the North Shore Aquifer is a little under 4%. Now, this green pie chart is a misrepresentation of water use in the two counties separate, because Nassau County does not use the glacial much at all. And the Magathie is the whole ballgame in Nassau County. We use about 90% of our water comes from the Magathie, and you would never realize that if you just went on what this chart is showing. So this is one of the flaws of the report, is that in some respects, it combines the conditions in Nassau with the conditions in Suffolk. And because Suffolk is so much larger than Nassau, it skews the data and the representations of what is going on. Here are some findings from the phase 1 study. In Nassau County, the saltwater intrusion along the north shore of Nassau continues despite some reduction in pumping. This is true for the UJM, that's the upper glacial, the Jamico, and the Magathie, and the North Shore and Lloyd aquifers. So all of the aquifer systems on the North Shore are promoting saltwater intrusion. On the South Shore of Nassau, there's also significant saltwater intrusion, and this is occurring primarily in the Lloyd and in the upper glacial Jamico and Magathie. In Queens, saltwater intrusion has been found to be very significant on the southern coastline of Queens. There's also intrusion on the North Shore of Queens, and these intrusion activities from the South Shore and along the North Shore are moving toward one another into central Queens. So Queens, you're going to be shocked when you see how much intrusion is in Queens. And in Brooklyn or Kings County, groundwater pumping began there officially in the 1870s. And saltwater intrusion was so significant that by the early 1900s, saltwater intrusion was extensive throughout Brooklyn. And even though they eventually abandoned the aquifer system and stopped pumping, conditions have not significantly improved from a saltwater intrusion standpoint for over 100 years. So just because you stop pumping does not mean that everything goes back to normal and is good again. This is a diagram of saltwater intrusion in the upper glacial, the Jamico, and the Magathie aquifers only, looking at the three counties, Brooklyn on the left, Queens in the middle, Nassau on the right. And this is an interesting diagram because you can see it's color-coded. And the colors are representing that portion of the aquifers, these three aquifers together, how much by percentage is intruded and it's color coded. So the green band is intrusion has invaded up to 25% of the aquifer. The light yellow intrusion has intruded up to between 25 and 50% of the aquifer. The gold or orange is up to 75%, and the red is over 75% of the aquifer is intruded with salt water. And you can see that there's a problem all along the South Shore of Brooklyn and Queens, and then up along the coastline up to the north, there's intrusion in Great Neck, and there's intrusion in the Manhasset Peninsula, and then over in the Bayville area on the North Shore of Nassau. So that's intrusion between the year 2000 and 2022. So this is a 20-year look at what we know about saltwater intrusion, where it is for these three formations. Now this is intrusion into the Lloyd and into the North Shore Aquifer, which you don't know where it is yet, but I'm gonna get to that. And again, it's the same thing that is color coded by the percentage of the aquifer that is intruded, and you can see a very large red wedge that extends into almost the middle of Queens County. You can see that the whole coastline of Brooklyn is intruded, and you can see a very substantial intrusion on the North Shore of Queens. And then additional intrusion into Great Neck, into Port Washington, and into the Bayville Center Island area. So saltwater intrusion is not only real, but it is significant in this western half of Long Island. This next couple of slides are going to look at the water table. Remember, that's the upper surface of the groundwater that is stored in the aquifers. And this is a view of all of Long Island. And that red line is the boundary between Nassau County, Brooklyn, and Queens on the left, and Suffolk County on the right of that red line. And you'll see here really clearly that Suffolk County is not only the largest county of the four, but it dwarfs Nassau County. The Brookhaven Township is the size of Nassau County. So what happens in Suffolk and the data that is generated by what happens in Suffolk, when it's combined with Nassau County, masks Nassau County conditions in a way that I think it complicates our understanding of Nassau County. And if you could see right in here, you would see that there are little circles in the middle of the island. Those are areas where the water table is 80 feet above sea level. So there's a mound right there in Oyster Bay, Central Oyster Bay, that's 80 feet. There's one just over the line into Suffolk that's 80 feet. And then further out in the Pine Barrens, Brookhaven area, there's a mound that's 70 feet. And this is what the water table looked like in 2010. So what I'm going to do now is, the reason I'm pointing this out is that the water table is not flat. And you can see that we can map how high the water table is above sea level all across the island. And the highest areas of groundwater are underneath the moraines, the high points. And then as you get further away on either side of that, the water table drops and drops and drops until it's just a few feet above sea level. And what we want to be able to do is to keep those mounds and the water table elevation as high as possible, because that is indicating that there's a lot of water in storage, and that helps keep out saltwater intrusion. So when we draw too much water out of the system, it lowers the water table. That diminishes the ability of the fresh water in the aquifers to hold out the ocean. And so that's what allows the ocean to start to intrude into the aquifers beneath the land surface. This is a blow up of the western Long Island. And so you can see here that circle in the middle, that's the 80 feet above sea level area. And then it drops down to 70 feet, and there's a line that marks the 70 feet elevation level. These are called water table contour lines. And so every point along one of those lines is that elevation above sea level. And you'll see that the line drops directly down to about 5 feet above sea level along the south shore. And then when you look up into Great Neck and into Port Washington, there's some individual mounds up there that are very unusual in that they kind of have an effect on ground flow up there. As you go into Queens, you'll see that the lines are farther apart, and there's not a high mound there. And so I'm going to just walk up here for a second and show you how this. The water flows from that mound down to the south shore. It flows from that mound out to Queens, and it flows from that mound up into Brooklyn, Queens, and northern Oyster Bay. So although it just looks like a mound of water, of groundwater, it's actually the engine that helps move water both deeper into the aquifer and feeding all three main aquifer formations, and also moves water to the north shore, to the south shore, and to the west into Queens as well. So just by looking at a water table map, you can understand almost immediately how groundwater is flowing through the aquifer systems, at least at the shallow level. This is going to be a quick lesson in the history of saltwater intrusion that has happened to us here on Long Island. So the first diagram on the left is looking at Brooklyn in the 1930s, and there was a water supply company called the Flatbush, Brooklyn, that produced water for Brooklyn. And these dashed lines are the water table. And if you could see them closely enough, you would be able to see that there's a minus sign. So as you go toward the interior of Brooklyn, it goes -10, -20, -30 feet. So it's showing you that the water table is not at sea level. It's 30 feet below sea level. And so they pumped so much water out of the aquifer there that they dropped the water table below sea level. All of these red dots are wells where the salt content of that well is 1,000 parts per million of chlorides, which is how we document saltwater intrusion. The drinking water standard is 250 parts per million. These wells have 1,000 parts per million in them. And so what is happening is that water is no longer able to, groundwater is no longer able to leave the aquifer and flow out into the ocean. The reverse is happening. The ocean is pushing in and starting to fill up the aquifer that has now been significantly damaged by excessive withdrawal of groundwater. So they had to abandon the aquifer in Brooklyn. The slide on the right, the diagram on the right, is around 30 years later, 1961. And now we're going to look at Brooklyn, in Queens, excuse me. And on the right, you'll see that there is the Woodhaven Queens Water Supply Company, and it's pumping a lot of water. And it did the same thing in Woodhaven, Queens, that happened in Flatbush, Brooklyn. They pumped so much water out of the aquifer that they created a hole in the aquifer that was below sea level. And you can see those dashed lines right there. And it went to 15 feet below sea level there. So naturally, what is going to happen? The ocean is going to try to push in and replace the fresh water in the aquifer with salt water. And again, the red dots now that are much greater, both in Brooklyn and now in Queens, are wells that have over 1,000 parts per million of chlorides. And finally, we come to the last slide, which is also Brooklyn. Excuse me, also Queens. This is the 1970s. This is the Jamaica water supply system, which was still in existence until a few years back. They pumped a massive amount of water. They did the same thing to the aquifer, created a big hole in the water table. It went down about 15 feet below sea level. And now we have more red dots that are showing a saltwater intrusion, and the ocean started to intrude this area as well. This also extends into Nassau County, the drop in water table. And water now is pouring out of Nassau County, groundwater is pouring out of Nassau County into Queens to try to fill this hole. And the ocean is doing the same thing, flowing inland to try to replace all the fresh water that was taken out. And it is starting to intrude into Nassau County as well along the South Shore. So you can see that we have a history of damaging the aquifer to the point where it cannot hold the water out, and the ocean comes flowing in and creates what we call saltwater intrusion. Okay, so I'm going to talk a little bit now about the aquifers. And then I'll stop for some questions. This is, again, how we have understood the groundwater system in the past. We've got the upper glacial aquifer at the top, sitting on the Magathie. On the South Shore on the right, we've got the Gardner's Clay and the Jamico. Then we've got the Raritan Clay below the Magathie. Then we've got the Lloyd, and then we've got bedrock. But when you see the aquifer in this way, you don't really have a sense of where these formations are. Are they everywhere? Are they just in parts of Long Island? You really can't tell. So one of the great things that this study did is it produced some very appealing maps of each of the aquifer formations and shows you exactly where they are and how deep they are. So I'm going to go through these new maps of the individual aquifer formations, and we're going to start at the shallowest formations, and then we're going to be like drilling down deeper and deeper and deeper and see where the other formations are. So we're going to start with the glacial, which is over everything. And right below the glacial aquifer is the Gardner's Clay. Remember? On this one, it's over on the right-hand side up near the water. See it over there on the right? Okay, so we're going to look at the Gardner's Clay first. And this is where the Gardner's Clay actually is. It's substantially in Brooklyn. It covers the south part of Queens and the south part of Nassau County, closer to the shoreline. And the colors are giving you the depth of the formation. So the darker blue is the Gardner's Clay that goes down to almost 200 feet below sea level. And that light sort of pink area is just a couple of feet above sea level. And it's just covered by the sand of the glacial aquifer. And the yellow is somewhere slightly in between. You can see that the Gardner's Clay is not really a big formation, and it's mostly it's a South Shore formation. This is the Jamico Aquifer that is just under the Gardner's Clay, and you can see it covers all of Brooklyn, a part of western Queens, and a little corner of southern Nassau County. And the darkest blue or purple area is almost 225 feet below sea level. And the light greens are around 50 feet below sea level. So you can see that it gets deeper as you go to the south. And it's mostly an extreme western Long Island formation. Now, we've never really publicly talked much about the North Shore aquifers, so we're going to take a look at those. This is, remember, we're starting at the shallowest areas and going deeper progressively. So this is a very shallow formation to start with. It's the North Shore Confining Unit, which means it's clay. And all of these irregular shapes, these finger-looking formations, these are erosion valleys that dug through the material that was Long Island as the glaciers started to melt back. And the water ran off the glaciers and eroded into the sedimentary material that the glaciers were sitting on and dug that area out. And so you can see there are two very substantial ones in Brooklyn, a really huge one in Queens, and then a variety of areas in northern Nassau County that are covered now in a clay layer that is called the North Shore Confining Unit. Now, clay is a barrier to groundwater. So this formation helps prevent good infiltration into the aquifer from the land surface. So water still gets in, but it has a hard time coming in directly from the ground above it. So this is a clay layer, and then below it is the North Shore Aquifer. So these erosion valleys filled up first with sandy material, and then at a later time, as they continued to be filled up, they were filled up with silty material and clay-like material that was the confining unit. So again, these are erosion valleys filled with sandy material that were later covered up. So when you're standing on the land surface, you don't know that you're standing on top of a buried valley because everything is now covered up and you can't determine that they're there from just the exposed land at the, on the ground. These become avenues for water coming in and going out of the aquifer system that could accommodate saltwater intrusion if necessary. And you'll see that in Brooklyn, these were areas where you had those big holes in the aquifer, where so much water had been pumped out that the water table dropped below sea level, and that coincided right there with that secondary erosion valley right there in Brooklyn. So these are the North Shore Aquifer. They are aquifers, they hold water, we can get water out of them. So here's the famous Magathy Aquifer. But you'll see that it does not extend all the way to the North Shore. And this is where you start to see the impact of where the glaciers came in, disrupted the geology of Western Long Island. And that's why we have the North Shore Aquifer on the North Shore, but we don't have it on the South Shore. So this is the northernmost boundary of the Magathy Aquifer, and then it extends to the full southward extent of Brooklyn and Queens and Nassau County, and extends out into the ocean as well. And this deep blue that you see here goes down to about the top of it. It goes down to about about 300 feet deep, and then it extends deeper than that. So the top of the Magathy Aquifer along that bottom area is about 300 feet below the land surface. Now, this is the brand new aquifer that the USGS has named. It's called the Upper Raritan Aquifer. And you can see that it's a fairly limited formation. It's sitting on top of the Raritan clay. It's sitting beneath the Magathy. And it extends about halfway into Nassau. It has this long extension into Brooklyn and a little bit into, a little bit into Brooklyn and a big extension into Queens. And its southmost point on the right of the slide, that is over 1,000 feet below sea level, to give you a sense of how deep that is. And then this is the Raritan clay. You see it's very extensive, and you can see where it's missing is where those erosion valleys are along the North Shore. And so this is another confirmation that when the glaciers came up onto the north side of Long Island and then started to melt, that meltwater had to go somewhere, and it drained off to the north side, the backside of Long Island, and carried all of this debris with it. In some places, it ate all the way down to bedrock. And so there's a groove in the bedrock itself in a couple of these erosion valleys. And then at the very bottom is the Lloyd Aquifer sitting under the Raritan clay. You can see that the southernmost point on the right end side of the slide is about 1,400 feet below sea level. So it's really deep down there. And again, you can see the erosion valleys on the North Shore. And this is the complication now that we're starting to understand in the formations and where they are and their history and how they can change how the groundwater is flowing and functioning as water moves from one formation to the next. Okay, I'm going to take a brief pause here. Are there any questions anybody has at this point about anything? Is this clear enough to you? What I'm showing? Yes.
How can you put an active balance?
Well, we can move away and just let nature take its course. It's very hard to revive it as an active practice. Any other questions? Okay. The next thing I'm going to show you is the complicated geology, now that you've seen where these different aquifer formations are. And I'm going to show you the aquifer system as it looks going right through the middle of Nassau County. I'm going to show you how it looks along the North Shore and how it looks along the South Shore. And what this map is showing you is a series of transects that then builds these aquifer maps that I'm going to show you. So we've got one line that runs along the South Shore that's called line A. There's another line that runs through the middle of Brooklyn and Queens, that's line B. There's a line that runs through Queens, that's C. Line E runs through the middle of Nassau County. D is the North Shore. So I'm going to show you first line E right through the middle of Nassau County. Then I'm going to show you line D right across the North Shore, looking at all the embayments. And then I'm going to show you line A, which runs all the way along the South Shore of Long Island on the the western side. Now, what I'm going to show you is confusing and complicated. So I'll try to explain it as clearly as I can. And just let me know if it's too complicated for you. So we're going to start with line E. Does everybody see where line E is? Anybody not seeing line E? Everybody see it? Okay. Okay, this is running through the middle of Nassau County from Long Island Sound up in Sands Point, all the way down to the Atlantic Ocean. So the Long Island Sound is on the left, Atlantic Ocean is on the right, and what we're going to be able to see is the different formations. They're color-coded to some degree, and anything in pink is saltwater intrusion. So anywhere you see pink colored areas, that is areas those are areas intruded by saltwater. So if we start up on the left-hand side of the slide, which is Long Island Sound, and just to refresh your memory, here's line E, and you see it goes all the way out the end of the Port Washington Peninsula. And it's going to extend all the way down, say, to Jones Beach. So first of all, we can see that there's upper glacial along the top of this diagram, which is clear, it's white. Then there's that kind of bluish color formation. That's the North Shore Confining Unit. And then below that is another white area, and that is the North Shore Aquifer. So in the extreme left-hand part of the diagram, we've got the glacial aquifer, then we've got the North Shore Confining Unit, and then we've got the North Shore Aquifer. These vertical lines that have numbers are monitoring wells. And the squiggly black lines are data collection that we can read and find out if there's salt water in that area, and also get a sense of the geology of that area. So as you work your way from left to right, follow that blue area until it ends. And where it ends is where the Magathy begins. So if you look to your right, you're going to see a light blue line. Above it, it says Upper Glacial, and below it, it says Magathy. And the Magathy extends all the way to the left until you reach the point where that thick blue area stops. And this is how much of the Magathy was removed as the glaciers came in and scoured the North Shore all the way down to bedrock. Does everybody see that? See that? Then, once you get to an area where there's Magathy Aquifer, you see this kind of gold area. That is the Raritan clay. And below it is the Lloyd. So we have no Lloyd on the North Shore. We have no Magathy on the North Shore. We just have the glacial, and we have the North Shore Aquifer. And that's it for getting fresh water out of the aquifer system along this transect running through the middle of Long Island, of Nassau County. So then we finally reach the point where we've got the glacial, we've got the Magathy. You'll see a thin layer above the Raritan clay, which is the new Raritan Aquifer, the Upper Raritan Aquifer, and then the Lloyd Aquifer. And those extend all the way down to the South Shore. And then on the Atlantic Ocean, you start to see the formation that is the Jamico down there, and the Gardner's Clay. So this is kind of like the conventional understanding that we have of the groundwater system, minus all the stuff that happened up on the North Shore. So this is looking kind of like a conventional version of the aquifer system. So that's the middle of Nassau County. What we're going to look at next is the line that cuts across the North Shore. So it's going to cut across Great Neck Peninsula, the Manhasset Peninsula, and Oyster Bay. It's going to start on the left in Little Neck Bay on the extreme western side of Nassau County. And then it's going to go through Great Neck to Manhasset Bay, go over Port Washington to Hempstead Harbor, then up through Oyster Bay and all the way across over to Cold Spring Harbor and the harbor there. Again, these lines are wells and the squiggly lines are data collection. But this looks kind of complicated, doesn't it? Because the North Shore is a mess. We've got a lot of pink in there that represents saltwater that has intruded parts of the material below the harbors, which is understandable. But you've got some deep aquifers that are intruded with saltwater, and this is a problem. So let's start on the left and work toward the right. So on the left, we've got Little Neck Bay in Queens, and we can see the upper glacial and the that is in pink, that's as salty. And at the very bottom, we see a bit of Lloyd Aquifer, and that is salty also. We've got some kind of gold material, gold colored formations. That's the Raritan clay in there. And then we've got all of this gray area, this blue-gray area, that is the North Shore Confining Unit. So you see they're all woven together and they join and then they disappear and then they reappear. So this is really complicated stuff, but basically what we see is in Great Neck, they have some upper glacial material. Almost the entirety of the aquifer along this transect under Great Neck is clay. And then you've got some Lloyd that is not salt intruded. And then as you move to the east, you come to Manhasset Bay. All of the material under the bay is salty. And then the material beneath Manhasset Bay, all the way to bedrock, is clay material, the North Shore Confining Unit. Then as you continue a little bit to the east, you pick up the North Shore Aquifer again. It is salty. Then you are coming into the Manhasset Peninsula. And again, it's got a combination of upper glacial material that is not salty, and then the clay, the North Shore Confining clay, and then below that you've got some Lloyd. Then you get to Hempstead Harbor, and again, remember the harbors are the erosion valleys. So you can see that they filled up with clay and sedimentary material back to the elevation that we know them to be today. So Hempstead Harbor, the material under it is salty, and then the clay goes all the way down to bedrock. As we continue on into the eastern end of the transect, we get into Oyster Bay itself. Now it's much above sea level, and it's got upper glacial material, a little mound of Magathy. You've got now Raritan clay in there, and then you've got a thick section of Lloyd Aquifer. Then as you continue east, the Lloyd Aquifer ends, the Raritan clay ends, and we still have some upper glacial, but we get the North Shore Confining clay again, sitting now on top of the Raritan clay. So one clay formation is on top of the other. And then we've got the Lloyd that is sitting right next to North Shore Aquifer material. And then as we get all the way over to Cold Spring Harbor, there's massive intrusion into the upper glacial. and there's massive intrusion into the Lloyd Aquifer there. Yeah. Well, this is just following a line. So this isn't everywhere on the North Shore. This is just along this one line. You open it up and look what's there. And this is what we find is there along that line. On either side, there may be more glacial than the other, and that's how they're getting their water. And this is a similar cross-section starting in Brooklyn and New York Harbor on the left and going all the way across the South Shore to the Nassau-Suffolk border. And what we see here is plenty of upper glacial aquifer at the topmost level. We see a little bit of the North Shore aquifer on the extreme left-hand side of this slide and North Shore confining unit clay as well. Then that ends. And we're still in Brooklyn at this point. And so let me just point one thing out to you. There are well numbers here. It starts with a K. You're in Brooklyn, Kings County. Everyone that starts with an N is we're in Nassau. So this is Nassau, this is Brooklyn, and this area right here is Queens. So the important point here is that in the area that is in Queens, look at all of that pink area is significantly intruded in the upper glacial, in the Magathie, and down into the Lloyd as well. And then as you extend on to your right, all the way over to the Nassau-Suffolk border, there's intrusion in the upper glacial, in the shallow aquifer. It doesn't show intrusion into the Magathie along this transect so far, and or no intrusion into the Lloyd. So I know that's complicated, but it expresses how complicated the aquifer can get. Okay, the last part is coming up, and I'm just going to show you some of what it looks like when you run the computer model and it gives you an output. And this is what the output looks like. So as I mentioned, there are different hypothetical situations that you can plug into the model and have it predict the results from those different conditions. And so these are the menu of conditions that you can pick from. Increase or decrease in recharge or precipitation, changes in pumping, changes in sea level, drought, saltwater conditions, salty conditions, and we wanted specifically to look at what would happen if we reopened the wells that are in Jamaica, Queens. So I'm going to just show you a couple of results. And what happened when the USGS built this map viewer, this is from the interactive computer program that anybody can use, is they did not build a function into it so that you can download the maps. So that you can see the map on the computer and you can understand it, but the only way to get a picture of it is to do a screen capture. So all of these are just screen captures, and that's why they are not as good as I would like them to be. This is looking at saltwater intrusion in the shallower aquifers between 1900 and 2019. Where the chlorides are over 1,000 parts per million. And you see a series of dashed and dotted lines running around the Great Neck Peninsula here. These are looking at different levels of chloride contamination as you go deeper and deeper into the aquifer formations. And you can see that it just skirts the northern tip of Great Neck. And so the light kind of gold color is looking at 1900, and the darker green is the Magathie in 1900, and then the other ones are recent changes in the location of the saltwater front. This next one is looking at Sands Point, and is looking at the same scenarios, the same range of years, the same fluoride levels. And you can see that the intrusion boundaries are further offshore for the most part than they were over in Great Neck. This one is looking at the deeper aquifer system in Great Neck and chloride levels in the different formations at a deep level. And you can see now that they've intruded into the northern part of Great Neck very significantly. And Great Neck does have a serious saltwater intrusion problem. And this one is looking at Sands Point. And again, Sands Point now has gotten very intruded, and they are dealing with the saltwater problem also. So you can, I just focused in on the North Shore as an example, but you can do this for any part of Nassau, Brooklyn, or Queens that you're interested in. So in wrapping this up, this is kind of a summary of the areas that are having saltwater intrusion problems. You can see that there's still intrusion in Brooklyn, along the shoreline as well as inland. These dots are showing the level of salt at these locations, and the big red dots are where the salt is between 5,000 and 20,000 parts per million of chlorides. So this is very, very substantially salty water. You can see that in the southern part of Brooklyn, there's massive intrusion from the South Shore and some very big areas of intrusion. And then up on the North Shore, you can see multiple areas of problems in Great Neck. Is not quite as bad in Manhasset Peninsula, and then problems out in Bayville and the Center Island area. So these are active saltwater intrusion problems over the last 20 years. So this is wrapping it up. Just an overview on what is not happening right now with our water supply. Unfortunately, right now, at this point in time, we are not having any discussions about what will be the actions needed to make the groundwater system sustainable. Even though the study is called the sustainability study, we're not talking about it. There are no proactive actions being discussed. The DEC, which is a co-director of this project, does not see itself as a groundwater management agency. It sees itself as a regulatory agency, and therefore it is behaving in a largely hands-off manner. There has been a failure to acknowledge that what is going on in Nassau and what is going on in Suffolk are two different things and will require different ways to deal with their individual situations. This is not being acknowledged at this point. The DEC is happy to have people engage in groundwater conservation and water conservation, but they have taken no active role in explaining to people why this is important. And this is a real failing on the part of the DEC. And at this point in time, and I mean as of today, the DEC is unwilling to use the model to undertake specialized studies for the North Shore, for the South Shore, for any other area where having the regional model gives us the big picture. If we want to zoom in on Long Beach or zoom in on Great Neck, those take a special set of modifications to the model, which are entirely doable, but the DEC is unwilling to allow that to happen at this time. What is being done is the DEC is promoting regional planning through an effort that they call the Long Island Action Agenda. And this is going to be a collaboration between municipal government, various kind of government agencies, and not-for-profit groups. And this plan is primarily intended to address water quality. The planning action, the action agenda group in the beginning had no one at all involved who had any experience with the groundwater sustainability study. And we managed to get one person onto the committee, sort of 2/3 through the process. And finally, the DEC is avoiding any discussion of how it could use its own regulatory authority to reduce water demand across Long Island. So finally, what can you do? Well, all water suppliers have been asked to reduce summer water use by 15%. Some are really taking this on as a mission, others not so much. So on your own, if you want to make a difference, you should look at your water use and try to reduce it, maybe not by 15%, but whatever you can get, that would be a great help. If you have in-ground irrigation systems, install the smartest smart controllers. Reduce your lawn irrigation to 2 times a week or less. Ask your local officials if they will make sustainability a priority and include it in future planning, and have water conservation become a main priority for Long Island. That's it. Any questions? Thank you for hanging in there. Yes.
What effect is the casino that's being planned for the Nassau Hub going to have on our water supply? Because they are expecting how many people a day? 30,000 a day, 10 million a year. And they're going to be using more water per day than they're using in the Carl Place area. So that's a concern we have, because we do not want a casino. But if the DEC is not going to talk about this, how do we get them to acknowledge that this is really not a good thing?
Well,
Just for questions for
Yes.
people on Zoom, to hear us, we need to be speaking into the microphone. So yeah, though that would be helpful if you would like to just say it really briefly so people on Zoom can hear us. Thank you.
My question has to do with the Nassau Coliseum turning into a casino, and the amount of water that's projected to be used per day is about 780,000 gallons, which is equivalent to the area of Carl Place. We know that the groundwater is not being recharged because we have the Meadowbrook stream that runs along the Meadowbrook Parkway, and they're expecting 10 million people, 30,000 a day to this area. And I think it's going to affect the draw on our water. We had heard that the Sand said that they would drill into the Lloyd, which I don't think they should be allowed to. They mentioned it. And I mean, we can't even, like you were talking about water running short. Roosevelt Field in the summertime when irrigation is used between the hours of like 2 in the morning to about 6 a.m., those wells run dry because of all the water being used. And those wells are contaminated. So what kind of, I'm just concerned environmentally, this will destroy our environment. And is the DEC involved in the casino process?
Well, with respect to the DEC, it will have to approve any well permit. Now, I know that the casino is proposing to pay for a new well to be drilled in Uniondale somewhere. The groundwater in that area is seriously contaminated. So whatever well they
We know
drill, the
that.
water will have to be treated. In their environmental assessment document, they had a higher number of water that they were anticipating at 875,000 gallons a day of water,
Mhm.
which is the equivalent of 319 million gallons a year. 319 million gallons a year. That's an awful lot of water for one facility. And so,
That might be underestimated because the other plan is there's on the drawing board is to build an NYU giga hospital on Nassau County community property that has not even come before the public yet.
right.
They have it in the plan, but it's our property and they have not had any hearings on that. So
Okay.
that's another concern.
Well, to put this in perspective, the communities along the shoreline that are suffering current or future risk of saltwater intrusion, it isn't their pumping that is putting them at risk. It's the collective pumping of everyone using the water. They're at the end of the pipe. And everybody else in the county is closer to the beginning of the pipe. So when they use water, when the communities, the inland communities use water, that affects the ability of the ocean to intrude along the shoreline. Because if there's less water in total in the system, there's less pressure to hold the ocean out. So it's not as if pumping in the interior has no effect on communities along the shoreline. So it's all one system. And, I showed the equation where the system had to be in balance. We're not in balance. We're taking more water out than is safe for the aquifer system. And we can see that with the drop in the water table, the drying up of streams and ponds, the intrusion that is taking place. So, all the signs are there that water demand growth cannot continue because it spreads pollution on the one hand, which is a quality problem, and it induces intrusion along the shoreline, which is another quality problem produced by a quantity issue. So,
Well-
the issue with going into the Lloyd is that it would be flatly illegal for the DEC to issue a Lloyd permit to anybody in the interior of Nassau County. There's a moratorium in place now that legally prohibits the DEC from doing that. So, it may come to a fight over the Lloyd if the DEC, for some reason finds it's okay. They're going to get litigated. But that will put further demand on the Magathy to meet the needs of a very large and concentrated area of water use. And so we'll see what happened in Brooklyn, where they dropped the water table significantly. if we get a big pumping center, which we already have one, we've got Hempstead there, the village of Hempstead with all their wells kind of clustered together. And then you've got Uniondale to the south. So there's a large water demand in this central hub area already, and the supply provided by the town. So, you know, adding another couple of big users in that same area is going to be a big problem. They may not be able to meet the demand with the water that's there now. They may have to bring it in from other areas through some kind of dedicated pipeline.
Well, thank you for explaining. And I think that's going to sink them because we're after them. And I encourage everyone to go to the hearings. Just file your letters, contact the DEC, you know, because it's all there. We have it on our website. And we've been working at this for how long now, Rich? 2 years. 2 years, fighting them. So we can't have this or we're going to be destroyed. It's like the canary in the coal mine telling us. Thank you so much.
Thank you.
Sarah, I mean, oh, sorry, Rich, go
I
ahead.
just wanted to clarify your comment. You're right, they did have 835 million, now they have 760. It's been all over the place, but with that water, when they take up that much water, how does it impact the surrounding wells? You know, Garden City is not very far from that massive well they're talking about, up to 2 million gallons a day would be the capacity of that new well. And they claim 760,000. Will there be movement of water underneath? Could it impact the movement of the pollutants, for example, to potentially come in our direction?
It could alter the flow of some of the plumes. Most public supply wells now are in the 1.5 million to 2 million gallons a day rate of pumping anyway. So it's not an unusually large well, but wells are rarely on 24 hours a day, all day long, all year long. They go on, they go off as demand fluctuates over the course of the day and over the course of the summer. The big demand period is the summer because overall water use increases 200 to 400% in the summer because of all of us. And so when you add on to that, you know, another big demand center, it is going to have an effect on the system.
No, I appreciate your presentation. It was excellent. And I don't think our legislatures understand what happened in Brooklyn, you know, with mismanagement. Now you have undrinkable water under the entire borough. And we really have to protect Nassau County because once it's gone, I guess you can't get it back. So I think that's an important message that we have to get out to people.
Hey,
Thank you.
Rich, I think what we should do is like have Elizabeth work with Sarah and we should write this up as bullet points and somehow explain this to the village and maybe even get it out to Newsday, because I don't think anybody's really gone through it in detail like this and through the basics. Not that I think everyone could go through the whole presentation. I think we'd lose people, but just the last part that you said and summarized, I think we should ask if you and Elizabeth would put that together and then we can put it out. We can even talk about it in one of our BOT meetings. Because I think that if people saw that or heard that, they'd get scared.
I don't think they realize the salt water.
Yeah, I don't think people realize it. And I really don't. I don't think that, I mean, they talk about the aquifers, but they're like, yeah. Because I remember reading this stuff for that Audubon Society that the gentleman sent over to us. And I was reading it and I was going, yeah. You know what I mean? But when you listen to what you have to say here, especially the last 10 minutes, that's frightening.
Just one little question with what you had mentioned. All right. The sands use is going to be a continuous use at about 800,000 gallons. All right. They probably will not have a summer surge that you have in residential areas. So the impact is going to be a continuous number surge. Whereas when you look at other communities, yes, the summer is what kills you, but the winter is not so much. So it's a very different water usage system that they're proposing compared to all the municipal units around it. because almost all of the use right now is dictated by residential use. And you had mentioned only like 20% or so commercial. That well is going to be completely and totally commercial. And the use will be a constant number. I don't suspect it's going to vary by more than about 10% summer versus winter.
We bring up a really good point because the way the aquifer system recharges is it recharges from September or October to May in the winter, when we get a lot of rain and very low demand. And we don't have plant growth taking up the water and stuff. So right now we're in basically an invisible drought because we're in the winter and rainfall now is very low. So in the winter, the aquifer recovers. And the rain in the winter is what keeps the system going over the course of the year. If you're going to have a well that is pumping more or less at capacity all year long, it inhibits the groundwater system in that area from recovering. So it will have multiple consequences. And you had a question?
Yeah, to Brooklyn, I think at one of our meetings a couple years ago, someone, maybe Liz, told us that Queens and Brooklyn get their water pumped from upstate New York through huge pipes, right? So if we continue to negatively impact our aquifers, is that where we're headed?
New York City is not going to bring water to Nassau County.
So what would happen to us?
Well, we're on our own.
We'd
So,
have to grossly treat water, and desalination plants are very expensive.
so one of the things you mentioned was that the moratorium.
Yes.
The issue I see with that is that the license for the casino will come from New York. So if New York wants the casino to be built in Nassau County, they will deal with the moratorium and get it, give an exception so that Sands can build. well
Why
to
do you
Lloyd.
say that the permit will come from?
Well, New York has to approve the actual, there's gonna be 3 casinos that downstate have to be approved. And 2 of them are pretty much kind of given, we pretty much know where they're gonna be. The third site, unfortunately, right now, the lead seems to be that New York is going to select Nassau County. So if they believe it, if they select the site and then the bid is, we need to build the well there.
Those two things are not connected. Building the casino is not a de facto right to drill into the Lloyd.
I understand that, but I'm saying the license is gonna come from New York State.
Yes.
So New York State is gonna say in your bid, when Sands made the bid, they said, okay, we plan on doing this well. So if New York State then gives them the license, they're probably also gonna give them a waiver. Why do you think they would give them a waiver?
There has been, the Lloyd moratorium was put in place in around 1987, 86, 87. From that day on, there has been a very high level of attention given to keeping that moratorium in place and keeping the DEC in compliance with it. And the DEC, I don't think is willing to take the risk that no one would notice if they authorized a Lloyd well in the middle of Nassau County.
So do you think they would then approve?
They'll approve a Magothy well. They're not going to approve a Lloyd well.
Just to clarify, I think there were rumors that they wanted to go into the Lloyd, but from what I read, I think they plan to go into the Magathie for the 2 million gallons.
Well, then
What it says.
going with that, so the best alternative site would be in Flushing by Citi Field.
Yeah, they can get water from upstate. I mean,
The issue there is that if they're gonna, the water for that casino would be coming from upstate New York.
Well, great, but that's not Long Island.
Right, exactly. So that's actually a argument for it. One of the issues I see in Nassau County is that the people who live near the casino, Garden City, Carl Place, concerned about it. People who are in Manhasset, Seaford, not too concerned about it. But I think part of it is because, well, it's not near us, who cares? And, the revenue's going to come into the county. But I think that they probably aren't aware of how it's going to impact. I mean, those are the areas getting hit with the saltwater problem, but not really us. So, I think the vote was what, 17-1 is, am I got the number right when they voted? 18-1. It's close. But I think how much was that even on the table? Did they realize it's going to impact their water?
Well, one of the most active protectors of the Lloyd is Long Beach. They litigated every time there was a Lloyd well issue that came up going back into the early 80s and before that. And so they will immediately realize if there's an attempt to drill a Lloyd well in the middle of the county, that they're going to be in court the next day because they know how much at risk that would put their water supply.
They get their water almost exclusively from Lloyd.
Exclusively in the Lloyd, and they're having intrusion problems themselves. And they're on borrowed time at this point. So they're not going to monkey around with putting the Lloyd at any further risk than it is today for them. Well, at that.
Yeah, I have one quick question. So I think thank you so much for the very extremely informative presentation. So I think in the slides you mentioned the water to get the balanced water entering equals the water leaving the aquifer
Mhm.
plus the storage.
Yep.
So now I'm just trying to understand, now you have water coming and water leaving, right? So it seems like that should be a balance already without the storage. Would you mind
Let me
explaining
put
that a
this-
little bit more? Yeah.
This one?
First slide.
Yeah.
This is an interesting one because there's a mistake in the environmental, the DEIS. And it's an interesting mistake because it's been repeated historically over and over again by consulting firms in Nassau County. And they don't understand this equation. And so they said it in the report again, which is totally wrong, that as long as water entering is not greater than the water leaving, everything is okay. However, they don't consider the water that's going into the ocean, the water that's going into the streams, that's going into the estuaries. They only see water that's being pumped out by humans. So their view is as long as recharge does not exceed human pumping, everything is good. That is totally, absolutely 100% wrong. And even with that, there's just a little bit of room between what's going in and what's going out, even under their scenario. So they got the science wrong, and it completely changes how sustainable the whole scenario is. Because when you add the water that's naturally leaving the system and the water that is being pumped out, and then you're going to increase the pumping, then this is going to be more out of balance than it was before.
So water leaving the aquifers right here, it only includes human pumping, right?
It
doesn't
includes
include-
everything.
It includes everything.
Everything. And they want to look at only the pumping piece, which is a smaller part of the leaving the system piece.
I think, so water entering the aquifers equals water leaving the aquifers plus water in storage?
Okay, so here's the catch.
Yeah.
Water is sitting in the aquifer. Some of it is leaving, but the rest is sitting there.
Mm-hmm.
If more water leaves the system to send it out of balance, then the system starts to shrink to maintain the balance. So where are we really taking the water? We're not taking it from leaving the system. It's coming out of water and storage. We're depleting the water in the storage of the aquifer system. And people don't really realize that there's the natural discharge, and then there's the fluctuation of what's held behind. It's like a bank account. It's just like a bank account. You put the money in, some of it goes out to pay your bills, some of it stays behind as your savings. So if you overpay, what do you have to do? You have to take your money out of savings to cover the checks that you've written. It's exactly the same scenario. So if less money comes into your bank account, everything else has to adjust. If extra money comes in, then you've got more money in storage. And you can still buy what you want to buy and everything is good. So on aquifer, it works like a banking system.
Thank you. Yeah, I think I misunderstood it because I thought the water entering equals water leaving the aquifer plus water in storage. Actually, it's the water in storage is separate from the first part, right? And then the leaving and entering, it needs to be equal.
Right.
Okay, thank you.
You had said that the aquifers have decreased by 5%.
Uh-huh.
Is that kind of a static number, or is that seasonally? Does it change any by variable?
A gross generalization. Because to begin with, it's presented as a single number for the entire system.
Mhm.
But now Suffolk County is not in any kind of a water deficit. So the bulk of what has changed is what has happened in Nassau County. And if it includes Brooklyn and Queens, then that's even worse. But the big change that is still in a community that is dependent on groundwater is Nassau. And we're trying to get the next stages of the report to not be so generalized that you can't really understand the differences between how water is being used in Nassau and how water is being used in Suffolk. You know, Suffolk has all those massive septic systems, so they're not sending their wastewater to the ocean. It's not a one-time use like we have here in Nassau. So the situations are very different. The consequences are different. The outcomes are different. And I would say probably in Nassau County, it's more than 5% of a difference. But it's averaged out over a larger area. And so that's the way it turns out.
I would just like to share with you, the EAB board made a proposal to the Board of Trustees and we just passed it. So now we're offering a rebate program for EPA water sense labeled smart controllers.
Great.
So we are hoping more residents will switch from their traditional controllers to the very smart controllers in order to save water, because we did realize most of the water usage, like the peak water usage, that's a result of summer irrigation.
Yeah.
So that played a big part of it.
That's a wonderful thing. Congratulations. That's great.
Thank you. On Zoom. Oh, yeah. So now can you read? It's hard for me to read.
Questions typed out as well as someone waiting to speak. Like decide which one to go first.
Does somebody?
That's Jane. I can't see. Jane Jackson.
Oh, yeah, that is Jane Jackson. I'll read it here. The transect maps are a great contribution to the info the study provided, and your explanation of these is thorough and clear. What's the question, Jane?
No, it's just a comment.
It's a comment. Thank you for the comment, Jane.
Yeah, sure, go ahead.
Thank thank you for the presentation. Are there technologies or filters to remove salt water from the public drinking supply? The answer, okay, great. Are there technologies to take salt water out of the drinking water? The answer is yes. But they're expensive. And so it's not that there's not a way to do it, it's that it's very costly. And then the last one is, can we ensure the sustainability of our aquifers? And I'm not what it means to ensure the sustainability. We can do our best. And I think that's all that could be expected of us. But we're not being smart about it right now. We need to be smart about it. And I think that's it.
Do you
Are
have
there
more?
more? Oh, can you scroll down? Okay. Do you know anyone at Newsday or Channel 12 who might be interested in doing a story about our water vulnerability? I think Trudy Toulis was doing some of the water stories. I don't know if there are others that are doing them now. Are there any more?
It's, yeah,
But it's the same.
Eddie has his hand up.
But I think that's the person that wrote the question at 9:21.
Oh, okay.
Aren't answering them.
is Eddie still there? Yes,
Yeah,
right?
that was my question. Thank you.
Okay, that was his question.
Okay. Do we have more questions?
Any more questions from anybody?
Always miss this, thank you.
There you go. Would those costs of desalination likely fall to municipalities, or would the state or federal government offer funding? Are there examples of this in other parts of the country? Thank you. Yes, California is doing a lot of desalination. Of course, Israel is doing a tremendous amount with it. I don't remember, there may be some places in Florida that are doing it. So it isn't that it can't be done. The cost is coming down, but with what's going on at the federal level, I don't know if there will ever be more federal funding for it. But anyway.
Do we have more questions in the audience? Thank you so much, Sarah, for the excellent presentation.
Thank you.
I think we all learned a lot. Thank you so much. So do we have a motion to adjourn the meeting?
So moved.
All in favor? The meeting has been adjourned. Thank you, everyone.